So we can use what we know about limiting reactants in order to calculate theoretical yield. So if we know the amount that we have of our two reactants, or three, or however many it has, for our purposes, we're going to have two. If we know how much we have of both, and we know the balanced equation, we can figure out what the theoretical yield would be for each sample in order to determine which one is the limiting factor. Okay, so first we convert both of our grams of samples into moles of that reactant, and then we use the ratio of from our balanced equation in order to determine which one is the limiting reactant. Okay, so it makes more sense whenever you kind of see the math all drawn out. Okay, so step one is you want to find the molar mass of each reactant and one product. Okay, in this case, we only have a single product. We don't have more than one, but in some of your example problems or practice problems, you might have more than one product. Based on the question, determine which product you should find the molar mass for. Okay, so I find the molar mass of all three of my different compounds. So for this one, aluminum, there is no subscript, so there's just one, and then times the mass that I find on the periodic table. Okay, for chlorine, there's two of them, so 2 times the mass on the periodic table. And then for aluminum chloride, there's only one aluminum, times that by its mass, and 3 chlorine times that by its mass, and then add those two numbers together to get the total molar mass. Okay. Next, what we want to do is convert the mass that it gave us into moles using the molar mass that we just calculated. And then using stoichiometry, okay, which is just those ratios that we were practicing before, determine how much product each would produce. Okay, and then the key thing it says is that the one that produces less will be the limiting reactant. Okay, so if we have 2.8 grams of aluminum, we're going to convert that to moles. So because I have grams up here, I need grams down here. If I look at my chart, I calculated that the molar mass is 26.982. So I have that down here in 1 mole of aluminum. Okay, so now I'm in moles. So I need to look at the ratio of aluminum to aluminum chloride. Okay, it's 2 to 2. So for every 2 moles of aluminum, it's going to produce 2 moles of aluminum chloride. Okay, so I have moles here of aluminum, moles here of aluminum, 2, and it's going to create 2 moles of aluminum chloride. Okay, I now need to convert this into grams. So I know that in 1 mole of AlCl3, okay, because I'm dropping down with the units that I had, is equal to 1.33.32 grams. Okay, here. All right, so then I would multiply across, and then divide, and I would get 13.84. Okay, we're going to do the same for chlorine. So they gave us in the problem that we have 4.14 grams of chlorine. I drop my grams down here, use the molar mass that we calculated, so 70.9 grams in 1 mole of chlorine. Okay, then using the ratio of chlorine to aluminum chloride, okay, I have 3 chlorine to 2 aluminum chlorides. So because I had chlorine here, I have to drop it here. So 3 to 2 moles of AlCl3. Okay, again, I need to convert this to grams. So because I have moles of AlCl3, moles of AlCl3 gets dropped down to the bottom. And then I use the molar mass that we calculated. Okay, multiply across, and divide, and I get 5.19. Okay, you'll notice I circled this one because the one that produces less is the limiting reactant. Okay, so 4.14 grams of chlorine is the limiting reactant when mixed with 2.8 grams of aluminum. So if we had enough chlorine, we could produce this, but with only 4.14 grams of chlorine, it can only make a maximum of 5.19 grams of AlCl3. Okay, so the total theoretical product that's being produced would be 5.19 grams. Okay, for this example, First, it asks what type of reaction this is. It is being mixed with oxygen, and it is a hydrocarbon because it has carbon and hydrogen. So this is a combustion reaction. In order to start this problem, you would first need to balance the equation so that you can get your ratios for the stoichiometry part of the equation. Okay. The next thing that I would do is I would find the molar mass of my reactants. Okay, so of this, and then remember of one of my products. In this case, it asks how much CO2 is produced, so I would want to find the molar mass of my CO2. Okay, then once I find the molar mass of those, I would take the amount that they give me, so I have 76.4 grams of C2H3Br3. I would convert that to moles and then use the ratio from my balanced equation in order to convert to moles of CO2 and then convert that into grams of CO2. Okay, and then I'll do the same steps for oxygen. I'd find out which one produces less of the CO2, and then that's going to be my limiting reactant and will tell me how much CO2 can be produced from the two amounts given.